Thank you very much. So my name is Matthew, and I've been working on natural capital accounts and economic measurement for about the past 10 years, and I think I finally made it. I'm here at the ONS. You guys are genuinely world leaders in pioneering and innovating new ways to measure 21st century economy, and particularly around natural capital. The UK is a global leader. And this shows up in the contributions that people from the ONS and from DEFRA and from UK academic institutions make, for instance, to the UN process in developing system of environmental economic accounts. So it's a long-winded way of saying I'm really grateful to be here, and I hope that the work that we've been doing here at Cambridge that I get to share with you today is of interest to you guys and will be stimulating. So first thing I should say is that this is joint work, so I can't take all of the credit. It's with Professor Diane Coyle, Dimitris Angelis, Marco Felici, Saite Liu, and Yulia Vidovin. This is our team on the Wealth Economy Project at the Bennett Institute for Public Policy at Cambridge. The project's just over a year old now, and we're motivated by the fact that, or the observation, I suppose, that 20th century statistics aren't going to get us where we need to go in the 21st century economy. They're outdated, they're a bit obsolete, economies are changing, and as they do, so must our tools of measurement. And we're interested in moving beyond just GDP and income flows and looking at the capital assets, the broadly defined base that makes up the economy. And for our project the first year, we focused on natural and social capital for two completely different and opposite reasons. Natural capital because there's so much great work done in the area and we think we can add to it by putting in some new perspectives. And social capital because there's been relatively little progress in measuring this at a national or an international scale. And so we thought maybe there's some first mover advantage still available to us. That's how we picked it. I'm going to try and speak for around 40 minutes, 45 minutes, and if you have questions of clarification, please just stop me as I go. If you have substantive questions, we'll have time at the end to deal with them. If at any point you feel like zoning out for the rest of the time, just remember these points and the job's done. So when we're talking about wealth accounts, natural capital, social capital, human capital, produced capital, we're talking about a future-looking, a forward-looking assessment, forward-looking measurement. The value of an asset today is a function of what it can do for me in the future. And so if we're trying to capture that in an account, we cannot just look backwards in historical evidence to tell me the value of that asset. It's based on expectations. And as economists, we do, for better or for worse, influence those future expectations. So when we make statements about the economy, when we make policies about how we invest into an economy, we are, whether we like it or not, whether we admit it or not, picking and choosing assets, picking and choosing wealth, picking and choosing value, and it has a forward-looking impact. So we need to recognize it, but we can also use that as a tool to our advantage and direct it. So it's future-focused. Social capital is largely missing. We know it's important. We know what happens when we have a breakdown in social capital. We have a lack of trust. We have rising crime. We have political institutions that don't represent the population they're supposed to. We have a lack of legitimacy. We know what happens when social capital is not there. What we need to do is figure out how we can measure it so we can understand how best we can foster it. And then the next piece is about changing the perspective for economic measurement. And I suspect this is where I'm going to get some pushback, because the Office for National Statistics has a mandate for which country, or, for its boundaries, for its system boundaries. And what I'm going to try and convince you is that although we may have a legal mandate, although the ONS may have a strict mandate from government as to what it can measure, what have I done? I've taken too long on one slide. Terrible crime. So as long as even though we may have a mandate of focusing on the UK, the reality is the global economy and the UK's role in that global economy doesn't. And so we need to be able to understand and account for impacts and measurements across borders. And that's a defining feature of the next century of economics. So this is my theory slide. It's not what most economists would put up as a theory slide. It's about 60 years of calculus here, which tells us that the size of the pie in the future depends on the stock of ingredients in the pantry. And if you're running out of ingredients in the pantry, then tomorrow's pie will be smaller. Of course, we're not talking about milk and eggs and butter and sugar. We're talking about the broadly defined wealth assets that make up the base of the economy. Things like human capital, social capital, natural capital, produced capital, etc. And so what I want to do is figure out how we can start measuring the assets in the pantry, because that's what determines future growth. It's a future-looking issue. So we have these 6 capitals. Different people categorize them as 4, as 5. It's physical assets, infrastructure. It's human capital, the skills and knowledge and health of the workforce. Intangible knowledge assets, intellectual property, data. There's financial capital, which we're all aware of. And the ones we're going to focus on are natural capital, those stocks of the environment that generate flows of services for people over time. Things like a stable climate system that enables us to produce and live in a comfortable environment. And social and institutional capital, the relationships and trust that we have amongst individuals. And in future work, we're going to be linking this through to total factor productivity impacts. So this is the broad framework, and we'll focus on 2 components of natural and of social capital. I think I've made the point that wealth embodies the future. So the value of these assets today is determined by what we expect to be able to get out of them in the future. If we make the expectation that we are going to continue to invest in the fossil fuel-based economy, we're going to continue to build fossil fuel-based infrastructure, roads for individual cars to be driven with a range of 250 to 300 miles. So there's a filling station on the motorways for the fossil fuel cars. Then we'll continue to use fossil fuels. We'll lock that in. We build coal power power plants. We'll continue to use them. If we make, and that will keep the price of fossil fuels high. If instead we make a concerted decision to shift out of the fossil fuel-based economy into renewables, as we are starting to do, we will see that we get better and better at producing and deploying renewables. They come down in price, and they start to actually outcompete fossil fuels. And this is what we're actually seeing. We're seeing the price. This is battery storage, and this is solar PV deployment. The prices are crashing, and they're now outcompeting fossil fuels in all parts of the world. In fact, the ONS's own estimates show that fossil fuel values, coal values, particularly in the UK, over the past 15 years have crashed. While at the same time, renewable generation has increased, I think, 7-fold. So that tells us a little bit about which assets we might want to hold. When we start developing accounts that tell us about price trends and the value that we're getting from these different classes of assets, it starts to give us a different view on what we want to hold in our pension portfolios, and a different view on where we want to start making public investments. So what I'd like to do first is dig in to a little bit of the new research that we've had on social capital. And this is work with Marco Felice and others. And going through the literature tells us that essentially what we're really looking for is the level of trust that exists in a society. Social capital, broadly defined, is the ability of a society to overcome collective action problems. And we can measure this by understanding how well people trust one another. Do you trust your neighbors? Do you trust your family? Do you trust institutions? And we have data on this from the European Social Survey. So we use 8 waves of the survey, which includes 10 trust questions, 7 of which deal with how much do you trust institutions like the courts and the police and parliament, and 3 deal with trust in people. And we conduct principal components analysis on these to uncover some underlying trends, some underlying traits. And when we do that, we're able to identify 2 components. And combined, these principal components, they reduce the variation in the original data and explain it in just 2 components. About 65% of that original variation is covered by just these 2 components. And the first one, which we've named generalized trust, correlates strongly with all of the individual trust questions, positively with all the individual trust questions, and it describes about 50% of the variation in the original data set. The second one has a completely different interpretation. 3 of the questions correlate positively, and 7 of them correlate negatively. And what that tells me is that it's contrasting between people who place relatively more trust in people and those who place relatively more trust in individuals. And I'm going to show a couple of graphs with the actual results. And the way to interpret them is that the 0 line, the bar in the middle, is the European average. So the data includes 30 countries across Europe. Depending on the year, countries change a little, but it's broadly 30 countries across Europe. And we took a look at the variations in this trust across time for different age groups and different income groups. So if we take the if we take the age groups, the first trend that we see is that younger people generally have a higher level of overall trust, that older people generally have a slightly lower level of general trust, and that the gap is widening over time. Now this is correlation. This is not causation. I'm not making a causal statement here at all. We're just analyzing the data, trying to get a sense of what the numbers are telling us. And if we look at income as well, we see that the lowest income quintile tends to have less general trust, lower general trust scores on the survey questions than the European average, and that the higher income gives us a higher than average score. It looks as though there's a break here at 2008, and this is, I'm pretty sure this is because there's a change in the way that income is measured in the survey, and I wouldn't want to overinterpret that sort of structural break. Again, these are correlations rather than causation. And it starts to give us a sense of where the trust levels might be at different income groups, different age groups. But the issue is, when we're young, we also tend to have a lower income. When we're older, we tend to have a higher income. So we need to sort of suss out these differences. And so we did. Basic regression analysis. We have the generalized trust principal component for income groups and age groups. And let's just stay with this one first then. The reference group for incomes is the lowest income quintile. And this confirms what we had in the previous graph, even when we control for a suite of other socioeconomic factors. The country, the date, gender, education, inequality measured by Gini, the frequency of social meetings, so some of the other social capital variables, and whether or not you're part of a union. Okay. We still see that higher levels of income tend to have higher levels of general trust. And we still see that higher age groups tend to have lower. This small blip here is statistically indistinguishable from zero. So I make the claim. Now, if we look at the contrasting component, the one that tells us about trust in institutions versus trust in people, we still find very similar results from the previous slides, right? So that relatively higher income, there's relatively more trust in people. And we find that relatively older place relatively more in people. Right. Now, the problem is that we don't have panel data, so we're not following individuals over time, so we can't make a causal statement. I cannot say that higher income causes more trust. This is an area for future research if we can get the data.
Sorry, I'm late.
Lucky to have you. So this work, the preliminary work, has now been picked up by the UK's Industrial Strategy Council on measuring social capital, and they will be using this to assess the success of the industrial strategy. So we're going to be working with them continually over time with more specialized UK polling data, so we can build up the sample size within the UK, so we can make more robust statements about it. Now, I'd like to shift now. So that's the basis of the work that we're doing on social capital so far. The next step is going to be linking that to changes in total factor productivity. We have some preliminary work on it, but the numbers bounce around a bit, depending on whether we're using OECD data or Penn World Tables data. So I didn't think it was quite ready to bring to you yet. But when we get there, I hope I'll be back to speak about it. So now the piece that I think is probably going to get more pushback from the ONS audience, I hope. Because I'm interested in going beyond the national borders and developing accounts that do so. I think that developing accounts solely on the basis of the borders that we have misses too much of the important stuff that's going on in the global economy, and particularly when it comes to natural capital. And I'm going to use just the example of carbon emissions to demonstrate why this is so important. A stable climate system is a natural capital asset. It helps us produce. We adapt to the climate. We build our buildings. We develop our industries within a particular climate. If that climate is stable, we're able to update and respond to it. Right? It doesn't change that much. Carbon emissions are a depletion of that natural capital stock, that climate capital stock. Every time we emit a ton of carbon, we destabilize the climate a little bit more, and we erode that capital asset. We know that we emit, I think it's about 55 gigatons of CO2 last year, totally as a species in the global economy. So we know that we are reducing global climate capital by 55 gigatons of carbon times the price of carbon. That's the value of the loss in global climate capital. We need to account for this. So we know when we release the emissions, we reduce capital, we reduce wealth, but whose? And that's the question we're trying to sort out here. So how do we attribute this loss in wealth across countries? Well, I can think of 4 ways. The way we do it now, and the way we've done it for years, in the Kyoto Protocol, in the Paris Agreement, the way that we'll take the front stage at the COP in Glasgow, is we attribute emissions based on this production principle. We attribute them to the country in whose borders those emissions were released. So if we combust the fossil fuel, we own it. We own that carbon. And that's true regardless of where those fossil fuel stocks came from. And it's true regardless of where the products and the services that we generate with those emissions go. So it places no liability on the consumer. So that if we import carbon-intensive goods from India and China, we have no carbon liability for that. India and China take it all because it's in their production. Now, so we have now two perspectives. We have the production perspective, which is dominant in global climate policy. But we could also think of a consumption perspective, where the consumers have the liability. Right? We do this for other sin industries. We say that we have a responsibility not to purchase goods made with slave labor or sweatshop labor. And that's a liability on the consumption side. There's a lot of debate about whether we should be using a production or a consumption-based accounting system for attributing those carbon emissions. But what I'm going to say is that that entire debate, whether we attribute it entirely to the producers or entirely to the consumers, is utterly irrelevant when it comes to measuring wealth, those natural capital stocks. And the reason for that is that the incidence of the damages from climate change have nothing to do with the processes that determine where production and consumption take place. Production and consumption take place in the countries that they do because of trade relationships, because of comparative advantages, because of historical relationships, etc. Right? But the incidence of the impact of climate change is driven entirely by the global climate system, not by policies, not by comparative advantages, etc. And so although there's a load of debate here, it's entirely irrelevant for the wealth economy, for assessing capitals, for assessing sustainability of countries. For that, we would need to know which country suffers the damage. And so what we do is we try and calculate that. And we attribute the emissions to the countries that suffer the damages. Now that is morally repugnant. There's no justification for me saying, India, you're going to suffer all these damages, or Bahamas or Tuvalu, you're going to suffer greatly from sea level rise. Therefore, you're the ones to whom we will attribute the carbon emissions now. That's not fair. But it is the world we live in. Until we have a globally binding, fully functioning compensation mechanism, whereby countries are compensated for the damages the global community imposes upon them through their carbon emissions, then that's the world we have. So we try to calculate these damage emissions and put together an account for it. First, for completeness, we take a look at the production and consumption emissions, and we get the standard story. Places like China, from a production perspective, have very high emissions, but they then end up exporting most of those goods, and so they have a net balance in the positive. Right? They're net carbon exporters. Countries like the UK, Japan, the US, net carbon importers. Right? We don't produce so many dirty goods, but we certainly do consume them. So the interesting bit is the damages. How do we actually calculate these and attribute them to the country level? I can think of two ways. Neither is satisfactory, but I think one might be preferable. The first way is that we use an integrated assessment model. These are the standard climate economic models that are used. The big one is DICE, for which Bill Nordhaus got the Nobel Prize. There's a regional run of DICE, which is called RICE, and that's what we use here. It breaks up the world into 13 regions and aggregates them to 8 regions for modeling. The US and China each make up one of those regions. So the rest of the world is distributed among 6 different regions. They put this through a great big model that assumes there's no trade except in carbon permits. And they assume that we can mete out the individual sectoral relationships between a change in climate, a change in temperature and precipitation, and economic output. And I think that's a bit more than we actually know about the economy. That's one approach. We use the integrated assessment model. A second approach is, let's pretend we're gods, right? And we can create 2 identical Earths. And we can warm one and not the other. And we can measure the economic outcomes. And the sole difference then between the 2 after a century or 5 centuries, however long we want to play the experiment, is due to the warming in one world and not in the other. Now, we're not gods. We can't do that. What's the closest approximation to that thought experiment that we can make? Let's say we want to compare the UK to another UK that's warmed. We don't have 2 of them, but we do have one UK, and we can observe it over time. And so we can compare individual countries to themselves over time. And that's what a group of climate economists at Stanford did, Marshall Burke, Saul Shang, and Ted Miguel. And what this allowed them to do was observe 50 years of history between temperature changes and GDP growth rates. Which means they don't have to pretend that they know about the individual sectoral and intersectoral relationships and how they're affected by climate change. All they needed was the macro trend. How does GDP growth rate change as a result of temperature change? And it bakes in, then, the trade relationships that are in the observed history over those past 50 years. Right? So I could use both of these approaches, and I want to be able to identify how much each country, what share of the global damages we should attribute to each country. Okay? When I do this using the integrated assessment model, like I said, 8 regions for the model to run. China and the US each constitute one of those regions. It means the rest of the world is grouped into these 6 remaining regions. And the groupings are made on the basis of, quote, political or economic similarity. Which means that Japan, Aruba, Canada, and Hong Kong are placed in the same group. Right? All of OECD Europe is in the same group. Right? But I could imagine, for instance, that Greece and Iceland would have very different responses to climate change, would have very different impacts. Right? Sea level change in Switzerland, not such a concern, perhaps. Right? Brazil, South Korea, completely different economies, completely different ecologies. Putting these in a group is severely unsatisfactory. And since we're talking about trade in implicit emissions, an autarkic model is tough to swallow. So I used both approaches. All right? But I'm only going to show the difference here between production and the damages. Okay? And the purpose of showing this is to say that these different accounting perspectives, remember there's a supply chain from extraction, production, consumption to damages. Where we attribute the emissions along that supply chain gives us a completely different map of the world. Okay? So these are shares of the global damage under the production perspective. Right? So the US gets something like 19% of the global damage, of the global liability, if we use the production perspective. Two things that are important to note. In the production perspective, no country goes below 0. Right? No country produces negative emissions. It's all positive. Okay? That's easy to swallow. From the damage perspective, the scale goes from severely negative, so a negative damage is a gain. Right? So some countries may benefit from early initial mild warming, and we see them here in blue. Right? And we shouldn't overinterpret that. This is early initial mild warming. And those gains, as we extend the time horizon out, collapse. Okay? Once you've warmed up a little bit, you don't get any extra benefit from further warming. We see the inequality between them is much higher. Okay? So we see some countries with some gains, whereas we have no negatives in the production perspective. The most important thing to get is simply that you have a completely different way of looking at the world when you use both accounting perspectives. It's not that any one of them is correct, but that if you use only the production perspective, which is what we do with Kyoto, and it's what we do with the Climate Change Act, it's what we do in the UN System of Environmental Economic Accounts, it's what we do in the Paris Agreement, right? Then we are imposing upon ourselves blinders that deny us this view of the world. And that's information we ought to have.
In this, you've moved away from the aggregate regions, haven't you? Spain and Portugal are shown differently coloured in that map.
Yes.
The underlying model, as I understood it, they'd be the same.
Yeah. So this is to link it back to the production and consumption accounts. I was using GTAP data version 9, which has 140 regions. So I aggregated the rest of the countries through the integrated assessment model and through the Berk-Sang-Miguel work for country level damages. They've all been aggregated back to the 140 country, right? Which is why, for instance, it's not that I'm bad at borders. It's just the data is limited. Yeah, good point. Should have made that clear first. Thank you. So we can look at the distribution of the attribution of the climate liability. This is a simple Lorenz curve. So we have along the bottom the cumulative proportion of the global population. So that 1 here represents all 7.5 billion or more of us. And on the vertical, we have the cumulative share of global emissions. So that 1 here represents, in this data set, the full 30,000 gigatons or so of carbon released in 2011. The black line, horizontal, is the line of perfect equality, along which 20% of the global population is assigned 20% of the global liability. 50% gets 50%, and so on. Any deviation to the lower right of that line of equality represents inequality, just as a Lorenz curve from Gini would. Right? And we see that the damage-based accounts are much more unequal. So if we are focusing our global climate policy and the UK's role in that global climate policy purely on this green line, we are missing quite a bit of inequality that we might want to consider. And we're denying ourselves this understanding of the world as well. How does this work for a developed country? Well, I've recently been asked to do some work for Australia. Prime Minister has been saying, well, you know, yes, these fires are terrible, but what can Australia do? We're only 1.3% of global emissions from the production-based perspective. Right? There's not much that Australian climate policy could do in response. Well, it's true, Australia is just 1.3% of global emissions from the production-based perspective. In fact, it's pretty much the same from the consumption-based perspective too. But from the damage-based perspective, it's between 4 and 8% of global damages, depending on the time horizon for which I run out the model. which means 4 to 8% of the global damages and just 1/3% of the global population, that the average Australian is due to be served 12 to 24 times more of the damages than the global average citizen. And that's a number that might interest the Australian people and Australian politicians. Regardless of what they do in terms of their emissions, this is what the global emissions combined with the global climate system is going to do to Australia. And so that might provide an incentive to change course, to change tack in both domestic climate policy, but also in its contributions on the global scale as well. So looking at both sets of accounts tells us a more complete story. The idea essentially, it's a long-winded way of saying that when it comes to accounting, perspective matters. Yeah? I'm not arguing for any one of these accounting perspectives, but rather that what we need is a suite of accounts, a dashboard. Every component of this is important, the production, the consumption, and the damages. And as long as we develop policy, and as long as our accounts only reflect one of these perspectives, then we are imposing on ourselves these blinders, and there's no need to do it. The data is good enough that we can do a much better job and have a more complete understanding. Now, I can stop here and we can do questions, or I can move on. I had some extra slides in case I got through things too quickly. So pick your own adventure. What do you want to do now? Q&A or a few more slides? Keep going? All right. So these are numbers that you guys created, so I'm sure you're familiar with them. So we can actually use natural capital accounts, wealth accounts, right now in the way that we design policies. They're good enough in the UK for use today. We know, thanks to you, that the natural capital asset value in the UK, I think the year is 2016, maybe it's 2017, is about £1 trillion. Joe's going to correct me if I'm off on the year.
Okay, that's right. That's right. More or less, give or take, 20 billion.
Right, okay. We know that £78 billion of value is added to property prices simply by being within half a kilometre of green space. Now, in a country that's going to be building more housing, I live in Norfolk, where we have a high population growth rate, and we are building everywhere. That's an important piece to understand as we design new developments. We know that from the ONS's own model, urban vegetation through deposition and stomatal uptake of air pollution has saved 27,500 life years in, I think that was again 2017 or 2018. I'm looking at Joe for this. He's nodding, I'm okay. And so that's something that we need to know when we design new cities, design new towns, when we update existing cities and towns. Right? We can link this through to other elements on the Treasury's balance sheet. If we know that we're saving these health impacts, we know that we're not paying for health impacts to the NHS. Right? We can start making these cross-sectoral value statements in actual balance sheets today for real policies. Right? The NHS can start planning. If we know that air quality is deteriorating in a particular area for a period of time, we know that in not too long we're going to have to bump up NHS expenditure to deal with the respiratory illness. We know that cooling and shading services, again, add value and save money. We can build this in to new design. I even put it in. This is your work. Great. So this is the piece I was talking about earlier. Which assets would you want to hold? Which assets would you want your pension to hold? Right? We see the red line here is the value of provisioning services from fossil fuels from 2003 to 2018. It's not a great trajectory. But we know that renewables have had a completely different trajectory. Now, if we took just the projections from the World Energy Outlook of what they expect renewable deployment to be, we would not get this line. Every single year for the past 20 years, they have systematically understated the likely rollout of renewables. So our projections are terrible, but what you guys have been able to show is that the deployment is actually pretty good. Right? And it's not just error in the projections. If it was error in the projections, I would sometimes expect them to project higher than actual, and sometimes lower. It's always wrong, it's always in the same direction, and our projections are always understating deployment. But we need the ONS data to show us that actually the value of these services is growing. And at UEA, I'm in the School of Environmental Sciences. At LSE, I'm in Geography and Environment in the Grantham Research Institute. And at Cambridge, I'm in a Public Policy Institute. This isn't just about environmental stuff, right? The natural capital accounts are not there for environment ministries to do agricultural policy. That's the wrong way of thinking about this. These are assets. It's capital. And in the same way that we manage capital in every other part of the economy, we need to manage these capital assets in order to give us a sustainable flow of benefits. Right? It's not about environmental policy, it's simply about, are we allocating and managing capital appropriately? So if we were to put this into, say, a macroeconomic strategy, what are the things we're interested in? We're interested in competition and growth. We're interested in macro stability. And the natural capital accounts, including the SIA system, which the ONS is fully compatible with, can speak to every component of this. Right? We can talk about how does environmental regulation increase or decrease competitiveness. Not just that it's an extra burden on some companies and industries that want to pollute, but that it's a benefit to the labor force that then generates higher labor productivity. Right? So we can start looking at these through the data that's coming through the national accounts. Right? When we're talking about stability, climate change is ripe with instabilities. Right? Political instabilities, environmental instabilities, and tipping points, but also litigation risks, reputational risks. Right? Companies starting to divest from fossil fuels. We have an issue of fossil fuel companies now facing lawsuits around the world, and governments facing lawsuits because of their investments and support of the fossil fuel industry. And we can start calculating depletion-adjusted growth, and we can start looking at what's going on in the assets, in that stock of ingredients that's in the pantry. Right? Natural capital is a core component of that. If we want to go more specifically to day-to-day activities at a treasury, right? We have the Fiscal Triangle, the things that really govern day-to-day activity, taxing, spending, borrowing. If the Treasury is interested in the viability of future revenues, and it sees the ONS graph showing what's happening to the provisioning services from fossil fuels, it's going to think twice about relying on them for a source of income in the future. Looking at natural capital investments and the way that we might want to develop new housing estates, new developments, we could be looking at different funding mechanisms for that. Working in green finance, performance bonds, etc. And of course, there's the spending side. As we see air pollution go up, coming from the ONS national accounts, the environmental extended accounts, we will see that in this area we need to have more money for the NHS. Right? We can take a look at how much we're spending on environmental protection and management and restoration. That's included in these accounts. And if we do that, we can understand what are we going to be spending or losing when we have sea level rise and storms that are taking homes out of the Norfolk coast. So we can start to understand these for real-world, day-to-day decisions in the actual Treasury as well. So that's the reason we're sort of doing this project. I'm grateful to the ONS for the work that it's done so far, and excited to be going forward with you on more natural capital and social capital measurement. That's what I've got for you.